Section 3.3, slope. Okay. Again, this is a review from Algebra 1. Okay, talking about slope. Slope is a number that we use to describe the steepness of a line. Okay, so it's what we use. It's a number that we use to define how steep a line is. So if I have a line with a slope of 10, it'll be steeper than a slope of, let's say, a line with a slope of 2. So it's a number that we use. Okay. How we come up with this number is we look at 2 points at random, doesn't matter which 2 points on a line. So if you look at this line here, we have our 2 points. This one right here is the point -1, 1. This point up here is the point 8, 8, 5. So if I wanted to talk about the slope of this line, I'm looking for how far up do I go for each unit over, okay? So basically I'm looking for how far up to get from this point to this point. Well, this point is up here at 5. So to get from where I'm at to up here, I would need to go up like this. So I actually go up 4 units. So 1, 2, 3, 4 to get to that same height. So we call that the rise. I go up 4 units. Okay. Now for the run, I'm looking for how far over then do I go to get from this point to this point. My run would be in this case 1, 2, 3, 4, 5, 6, 7, 8, 9. My run is 9. So slope is our rise over our run. How far up our rise over our run is 4. It doesn't matter which way you go. I could go the other way and do my run first. Again, run, think of running left to right, so you don't run up. You run left to right, so that's my run, and my rise is my distance up. I could go from this point and go backwards. In this case, my rise, I would have to go down. I would have to go down 4, so my rise would be in this case -4, and then I have to go backwards 9. So my run in this case would be -9. But again, still it's rise over run, so it would be -4 over -9. Well, negative divided by negative is still 4/9. So this is our slope, and we use the letter M for slope. Okay. Another way we think about slope, there's a lot of different ways. Here we say rise over run. You might be familiar with another way is to find the rise. In this case, to find this rise of 4, I take the rise as the y coordinates, right? So here I have a rise of my y coordinate here's 1. My y coordinates here's 5. So to find how far I go up, we take the difference between these two numbers, or we subtract them. I would take the 5 minus the 1 to get the 4. So basically we take our y coordinates and subtract them to find the rise. To find the run, here I have an x coordinate of -1, here I have an x coordinate of 8. Again, 8 minus -1 is my 9. So to find my run, I take my x coordinates and subtract them. So we would say y sub 2 minus y sub 1, x sub 2 minus x sub 1. Okay, again, this is review from Algebra 1. Okay, so we take the y coordinates and subtract them. The only thing to be careful of is to make sure it doesn't matter which order you subtract. What matters is that these 2 points, the x sub 2, y sub 2, are the same ordered pair. And that these 2 points, the x sub 1 and the y sub 1, are the same ordered pair, so you don't flip-flop. Okay. All right, so lines that go up here, my slope was 4/9. So, and if you notice, that's a positive number. So lines that go up have a positive slope as they go up from left to right. As I go from left to right, and if they go down, let's say this line connecting these 2 points here, this one would have a negative slope. Because it goes down from left to right. We can actually calculate the slope between these 2 points. This is the point, negative 1, 2, 3, 4, negative 4, 1. This is the point 1, negative 1, 2, 3, 4, 1, negative 4. Okay. So to find the slope, I could use this, or I could use my rise over run. If you use my rise over run, from this point to this point, I go down. So it's going to be negative. I go down 1, 2, 3, 4, 5. I go down 5. And over 1, 2, 3, 4, 5 over 5. So down 5 over 5. So my slope in this case would be my rise, negative 5, over my run of 5. So my slope would be negative 1. Or I could use my subtraction method from over here and take my y2 minus y1. So slope would be, so let's see, my y2, I'm going to have this be my point 2, and this one here be my point 1. So my y2 would be 1, minus my y1 would be negative 4. Here my x2 would be negative 4, minus the 1. 1 minus negative 4 is the same as 1 plus 4, which is 5. Negative 4 minus 1 is negative 5, so I still get a slope of negative 1. Same slope, 2 different ways of doing it. Okay, so lines that go down have a negative slope. Okay, let's look at straight vertical lines. Let's do a vertical line right here. Okay, first of all, the equation of this line, 1, 2, 3, 4, 5, 6, 7, 8, negative 8. So this would be x equals negative 8, because x is always equal to negative 8 over here. Okay, so then an ordered pair, here's 0, negative 8. And here's, I don't know, 3, negative 8. Oh, sorry, negative 8, 0, backwards. This is negative 8, 3. Okay. If I take my rise is 3, over my run, which is 0, I would get 3 over 0. You can't have a 0 in the denominator, so the slope of my vertical line is undefined. Okay. Whereas the slope of a straight horizontal, so a vertical is undefined. A horizontal, if we draw a horizontal up here, we're getting kind of a little cluttery, so I'll draw it small. A horizontal line like this has a slope of 0. And you don't necessarily have to remember that. You could always go through the process of finding the slope. Okay, so example 1. Find the slope of the line containing the given points. Well, I'm going to use, since I have the points, instead of drawing, I could draw a graph, plot the points, find the rise and run, or I can use my y2 minus y1 over x2 minus x1. A lot of times it helps. I'm going to make this point 1, this one point 2. So y2, so that'd be negative 1, minus y1 is 3. x2 is 4 minus negative 2. Negative 1 minus 3 is negative 4. 4 plus 2 is 6. Always simplify your fraction, so this gives me negative 2/3 is my slope. So I know this line's going to go down from left to right, down 2 over 3, down 2 over 3. Okay, let's do this one. Slope equals, you notice how I write the formula down each time? That's going to help me remember it, so write it down every time. So let's say this is 0.2 and this is 0.1. Again, it doesn't matter which one is which. So I'm going to take my y2, which is negative 4, minus my y1, which is 5, all over my x2, which is 3, minus my x1, which is 3. So I'd have negative 9 over 0. Oop, can't divide by 0, so this is undefined. So I know this is going to be a vertical line, and I could kind of tell that from here because the x-coordinates are both the same. So this is going to be the line x equals 3 will be the equation because x is always equal to 3. Okay. Next. Find the slope of the line. okay? There's two different ways of doing this one depending on what you remember, okay? One way number one, is to do an XY table and then take the difference. What I mean by this, solve for y, so then it would be, okay, you would solve for y. So when I solve for y on this, I'd have y equals 20 minus 5x all over negative 2, and plug in different x's and y's. If I put in an x of 0, I'd have negative 10. Put in an x of, let's go 2, that'd be 20 minus 10 is 10 divided by 2, negative 5. And then once I have the 2 points, use this. Because I have my 2 ordered pairs. I have 0, negative 10, and the point 2, negative 5. So I could have this be my x, my point 1, point 2. So I take negative 5 minus a negative 10 all over 2 minus 0. Negative 5 plus 10 would give me 5 halves. There's one way. Way 2. If we remember from Algebra 1, we have this y equals mx plus b, where m is our slope and b is our y-intercept, where you cross the y-axis. So if I can rewrite it to get it to look like that, I can very easily pick out the slope. Okay, well, I already have it in this form. Y equals 20 minus 5x over negative 2. I'm going to divide both of these by negative 2. 20 divided by negative 10 plus 5 halves x. If I rearrange it, I can tell here, that's a 2. I can tell here my slope is this part here, my m. Y equals mx plus b. Okay, whichever way you're comfortable doing. Okay, both of these ways work. Again, this is all review from Algebra 1. Number 3, graph the line through the point 2, 1, having the slope of negative 3 over 4. Find the coordinates of 2 other points. So I'm going to graph this. So let's go ahead and let's draw my coordinate plane. Okay, so here in purple, put our point 2, 1. X of 2, y of 1. There's my point 2, 1. It needs a slope, oh, let's use red instead, it's more visible, of negative 3/4. So if a slope of negative 3 over 4, so there's my rise, here's my run. Okay. So my rise, so from this point, I have a rise of 3, so that's down 3. 1, 2, 3, and a run of 4. So there's another point. So now I have a second point, I can connect the dot. Okay, some people get confused. I could also write it as 3 over negative 4. You will notice nothing's different. So from this point in purple, I have a rise of positive 3, so that means I want to go up 3. But I have a run of negative 4, I want to go back 4. If I do it this way. Well, look, there's my point in green, if you can see it. There's my point in purple, there's my point in red. You notice all 3 of these points are on the same line. And I can actually keep finding points by using this rise over run. Down 3 over 4. There's another point. Down 3 over 4. Another point right there. Okay, up 3, back 4. Another point right there. Okay, so there it says graph the line, which I did, put arrows on both ends showing it goes on forever. Find the coordinates of 2 other points on the line. Well, we found one. I can do this one in red. That coordinate is 1, 2, 3, 4, 5, 6, negative 2. Then I've also got this one up here. Negative 2. Negative 2 is my x, and then 1, 2, 3, 4. But here's another one up here. And then here was another one after I counted down here. And I can just keep using my rise and run to find more and more and more points. So we just want to find the coordinates of 2 other points. There are an infinite number of points on this. I could also use the halves. So here's this point right here. Here's this point right here. Here's this point right here. There's points all along here. But I just try to find the whole number ones because I like the whole numbers better. Okay, next page. You have 3 your turn problems, very similar to the examples I did. Jot down any questions you have for class. Feel free to watch the video again if you need to. Hey, and good luck.